2 episodes back, you wanted a sentiment classifier and we fine tuned one. But think about what that cost us: a labeled dataset, a training run, and a model that only ever knows the labels it was trained on. Back in the classifier episode, the labels were frozen at training time. If the product team showed up tomorrow wanting billing versus support versus sales instead of positive versus negative, you'd be back at square one collecting data. Zero-shot classification tears that constraint up. You hand the model a sentence and a list of candidate labels you invented 30 seconds ago, and it scores every one of them with no training at all. The labels live in your code, not in the weights. Here's the trick that makes it work, and it's beautifully lazy. The model under the hood was trained for natural language inference, deciding whether one sentence entails another. Zero-shot reuses that. For each candidate label, it quietly builds a hypothesis, like this example is about billing, asks the model how strongly the input entails it, and turns those entailment scores into probabilities. You never see the hypothesis, you just see clean label scores, one trained model, infinite label sets. So the labels become an argument, not a decision baked into the weights. You pass candidate labels, billing, support, sales today, and 3 completely different strings tomorrow, and the same checkpoint handles both. Nothing is retrained, nothing is reloaded. This is the whole pitch of zero-shot. The taxonomy lives in your Python list, where you can edit it in a heartbeat instead of being frozen inside a safe source file you'd have to rebuild. There's one switch worth knowing about. By default, the scores are normalized so they sum to 1 across your labels. That's multi-label low false, and it answers which single label fits best. Flip multi-label lows are true, and each label gets its own independent yes or no probability, so several can be high at once. Use single label for routing one ticket to one queue. Use multi-label when a document can genuinely be about billing and sales at the same time. We'll run single label here. The refund goes to exactly one place. Now the multilingual half. The default English zero-shot model only really understands English hypotheses, so a French sentence confuses it. The fix is just a different checkpoint, a model pre-trained on many languages at once. Swap the model name to a multilingual NLI checkpoint, and the exact same call signature now scores French, Spanish, German, the lot. Your code doesn't change shape, only the string naming the model does. And here's the part people miss: your labels can stay in English even when the input is French. The multilingual model has seen enough cross-lingual text that Je veux un remboursement still lands hardest on the English label billing. Or you can localize the labels to facturation, and it works just as well. The taxonomy and the language of the text are decoupled. One label list, many languages of incoming text. Step back and see where this sits on the map. This is pure run. Find a checkpoint on the hub, run it, read the scores. No dataset, no trainer, no eval loop, no GPU hours. When a brand new labeling need lands on your desk, zero-shot is the thing you reach for first, before you even consider collecting data. If the scores are good enough, you ship. If they're not, then you go fine-tune. It's the cheapest possible first answer. Let's read the file. It's one script, 14 zero-shot.py, and it fits in 2 short pages. Page 1 runs zero-shot on an English sentence and prints the ranked labels. Page 2 swaps in the multilingual model and scores a French sentence with the same code. Same pipeline, 2 checkpoints, that's the whole story. Page 1 opens by importing pipeline from transformers and building a zero-shot classifier in one line. Pipeline, zero-shot classification, models. We pin the classic English NLI checkpoint by name so the run is reproducible. Then we define our candidate labels as a plain Python list, billing, support, sales, right there in the code, because that's the whole point. The labels are ours to choose, not the models to dictate. Next, we call the classifier on the sentence "I need a refund," passing our candidate labels and multi-label are false. The pipeline hands back a dictionary with two parallel lists, labels already sorted best first, and scores lined up with them. We zip those together and print each label with its score to 3 decimals. So the top line reads, billing at 0.91. The winner is whatever sits at index 0. No extra argmax needed, the pipeline sorted it for us. Page 2 is the multilingual half, and notice how little changes. We build a second classifier with the very same pipeline zero-shot classification. Call. Only the model string is different. Now a multilingual NLI checkpoint that understands French. We reuse the exact same candidate labels, then classify Je veux un remboursement, and print the ranked scores the same way. Identical code shape, a different checkpoint, and now we're scoring French. Billing still wins at 0.8, which is the whole multilingual promise in one print statement. So that's zero shot. Find a checkpoint, hand it your own labels, read the scores. In any language with zero training, it's the fastest classifier you'll ever stand up. But notice we've never once left text. Every episode so far takes words in and gives words or labels out. Next episode, we leave text behind entirely. We fire up diffusers and turn a written prompt into an actual generated image. Words go in, pixels come out.